Hi students, this is our last new lesson of Unit 1. We're going to go ahead and get started. Let me get past some of these slides here real quick. Okay, so our learning goal today is we can evaluate two-sided limits from a piecewise function. So today we're going to focus on just given the equation, and we're going to try to find out what those two-sided limits might be. Same concept as we've done in the past, but this time we're going to do a little more where we actually evaluate using these different pieces. So the criteria for success to find two-sided limits of a piecewise equation, we will show evidence of finding both the left and right one-sided limits. You should be able to explain if you're approaching a value within a domain or on the end or beginning of a domain. You should also be able to explain how the, only one of those needed, continuity of your function affects the two-sided limit. Okay, this function right here is the only one we're going to use for examples today. So you just need to write this down once, and then we'll do several limits using this equation. So our first case is if the value you approach is actually on a continuous part of the function. So this is asking us when x approaches -6. And of course we want to think from the left and the right side. Now -6 lives inside this restricted domain. Okay, so that means we're only going to need to think about the left and right of -6 using this single first piece. Now let's think about this piece. Are there any discontinuities in a square root function? There should be no issues here from -7 to -3. So what that means is if I have this, no matter what point, if I plug in, let's see, so I plug in -6 and I get some point, well, of course, from the left and right, we're approaching that exact output. So this is the most straightforward example we can have, where really all you need to do is plug in the value of -6. Okay, so we would say the limit as x approaches -6 from the left of f of x, and the limit as x approaches -6 from the right of the same function. We know they're going to be the same. How do I find it? Well, I'm just going to plug it in. So I take -6 plus 7 under the radical and add 1. Square root of 1 plus 1 is 2. So now I can say, hey, the left and right are both going to approach that exact same value, and since they're the same, our two-sided limit is the value of 2. Okay, so this is for a continuous part of the function. Now the next case is if the value you approach is where one piece ends or begins. So the first limit we're going to look at is the two-sided limit as x approaches 1. Now look what's happening here. We see that the first one here is not included in the domain, but we would actually need to substitute it in for x to find out where that open circle or that unincluded point would live. The second one here, we have the bracket. So that tells me it does include 1 as the domain for that third piece. Okay, so let's go ahead and look from the left. So we'll say the limit as x approaches 1 from the left of this function. So we need to use this piece. This piece, as I get closer and closer and closer to 1, we're coming in from the left. So -3 is certainly to the left of 1. So is -2, -1, 0, 0.9, 0.9999. Those values are all within the restricted domain, and they are to the left of 1. This is why this would help us with the left-sided limit. So for this one, we would go ahead and put 1 in place of x, and the absolute value is just 1. Okay, now the right-sided limit. We want the limit as x approaches 1 from the right of the same function. We're looking here because look at where the values would be. If I put in 3, 2, 0.5, we could keep putting in, oh, sorry, not 0.5. We wouldn't want that. 1.5 rather. 1.1, 1.0001. Those are all just to the right of 1, which is how we can use this function as my right-sided limit. Now this is just a constant. So no matter what I plug in, it's going to output a 1. So for this, we can see that the left and right-handed limits, the one-sided limits, are identical. That tells me I have a two-sided limit as x approaches 1 of f of x that is equal to 1. We're going to do a couple more of these where we have the end or beginning of pieces. So -3 is the next value, x value I'm approaching. So look at this, -3 on both, and look at they're both parentheses. Now we've just kind of talked about this with finding domains, and it's very similar to what we've been doing with the domains. But remember, you could have a limit even if the value is not in your domain. It's just what is it getting closer to? Which output is it approaching? So let's do the same thing here, and we're going to approach -3 from the left using this function. So how do I approach -3 from the left? I use the values inside of here. So I would say the square root of -3 plus 7, and then plus 1 outside of the radical, which is the square root of 4, plus 1, which is going to be 3. Okay, now for the next one, we want to find the right-sided limit. So the limit as x approaches -3 from the right of f of x. Now, how do I approach it from the right? Well, I come in to this piece, and this is the part I'm going to use. So this is going to be the absolute value of -3, which is 3. So if we think of those two pieces, first of all, -3 is not included in the domain. But when I do substitute it to find out where that open circle is, it's at exactly the same spot on both. So this is a removable discontinuity. Both of those open circles are in exactly the same spot, and they're connecting the two functions. So it is not continuous. We would have to pick up our pencil just for that one tiny spot, and then we would continue on. So this limit, this two-sided limit, does exist, and it would be 3. Okay, we have one more of these shared little edges, which is +3. And I see here that 1 is included and 1 is not. Okay, so it's definitely part of the domain. But our job is to find out the left and right-sided limits. So if I want, let's say, the limit as x approaches 3 from the left of f of x, I am going to look at this. Okay, because how do I approach 3 from the left? It would have to be within this little restricted domain. Now, anything I substitute, I'm going to get 1 as an output because it's just this constant function. Okay, now let's see what happens as I approach from the right. So we're approaching 3 from the right of f of x. And so I'm looking at this piece right here. Because again, if I want to come in from the right, I need values like 5 and 4 and 3.5. It's in this restricted domain. So let's think about this. We'd have 1 over 3 minus 6, then minus 2. So this would be -2 and 1/3. Now, we definitely have both one-sided limits. However, they are not the same value. This is a jump discontinuity. And in that case, the two-sided limit does not exist. Our last part of this example here, case 3, is when a value we're approaching is at an infinite discontinuity. Now, at first glance, this looks just like case 1, because 6 is certainly somewhere in this restricted domain. However, we know this is not continuous, because if I put in 6, I'm going to have a vertical asymptote. It's going to be undefined. So we need to do a little bit of extra analyzing with this. And so we're going to say the limit as x approaches 6 from the left of this function. And now we're going to actually do a little bit of number crunching. So as I approach 6 from the left, what if we put in 5.9999? Let's just test it out, okay? So 5.9999 minus 6, and then minus 2. So if you were to take 5.9999 and subtract 6, you should get a negative small number. So 1 over a negative small number, and then we would subtract 2. Now, if you take 1 and divide by a teeny tiny negative number, you get a negative huge number. And then you're going to take 2 away. Now let's think if we did 5 point and like 100 nines, okay? Think about how much bigger this negative number is going to be, right? A huge number that is actually a negative in value. Taking 2 away, really not that big of a difference. And if something is just gigantic and negative, that's what we call negative infinity. So this is approaching negative infinity. Okay, now let's go ahead and take a look at the right-hand limit. So we'll do the limit as x approaches 6 from the right of the same function. Okay, let's kind of cap this off a little. So let's do the same thing, and let's do kind of a concrete example here. And you could, of course, make a table and put in many values as to get closer and closer. I'm going to do 1. I'm going to put in 6.0001, take away 6, and then take away 2 at the end. So again, this is a number just to the right of 6, and we're going to subtract 6. So we're going to get 1 over a small positive number. Take away 2. If I take 1 and I divide by something teeny tiny, I'm going to get something huge. And if I have something huge and I take away 2, that really doesn't make much of a difference. So this is going to be approaching infinity. So this is infinity here. Now, since negative infinity is not the same as infinity, this two-sided limit does not exist. Now, if we think about what we know about a rational function, this is going to move us to the right 6 and down 2. So our left-hand limit, so this is as we're approaching, let's say this is 6, okay? As we're approaching from the left, we found out we were getting closer and closer to negative infinity. And then when I zoomed in from the right, I'm getting closer and closer to positive infinity. So the end behavior we're seeing here is this and this, which are not approaching the same value. This is actually an infinite discontinuity. So at the value of 6, as I'm approaching from both directions, I'm going totally different spots here, okay? One infinity, one negative infinity. So the two-sided limit would not exist as we approach 6. Okay, definitely write down all your questions. Take your time with this. It's not an easy thing, so you really want to sit with it a little bit. Write down your questions, work on that review packet, work on your 1.3 homework, and then this coming week, we're going to spend some time reviewing and working on classwork and asking all the questions. So remember, write those down. Don't be afraid to ask. That's how you're going to be learning, okay? I will see you soon.